Okay, let me see. Can you guys see the meter? It should work. Hope so it doesn't blow up. Oh shit, I didn't buy a fuse. Flip it, that's not gonna work. There you go, 14 volts. Right, morning everyone. Welcome back to my channel. Today we've got a power supply that blew. Some say it's worked hard. Let me see how much space I've got where I'm working over here. This says it's worked hard. It runs my cameras and my DVR. I've had it for a while. It doesn't have a fan. I don't want a thing with a fan because it makes a noise. And at night it's nice to have. There's other sounds I like to hear. Dries has had a peep inside through the little holes. Gee, why is this not opening up? In any case, he had a peep inside and he says he saw, okay, the screws off there, the one cap that popped open. So what happened is, when that transformer in the area blew up, because nothing is looked after, the municipality is run by comrades who basically steal everything. So this will usually start back, okay, block that, a little warranty thing, whatever. Let's see that you guys can see properly. So multimeter, let's have a look. This, where you see the cap? Then you will see from that side.
That one.
Oh yeah. Okay, in any case, we'll test it. We'll test all these caps. So that's we'll test all the semiconductors, and then from there we'll test the capacitors. Right. Let's see what comes out of there. Test. Boom. Die tests, one of the rules is always check your meter leads. Right.
Sure.
That's on the, look here, that's on the rectifier.
Okay.
Huh? That's also possible, huh? That's right, that's a, no? Okay, that's a common one, yeah. Okay, that's fine. Let's turn this thing around so I can see it better. That's there. That's there. That's there. Nah, rectifier's fine. Rectifier's fine. We'll have to take the whole thing apart, at least.
Yeah, you have to.
Yeah, take the little thing that keeps the devices on. I hope you guys can see this. Okay. That keeps the little devices against the casing, which acts as a heatsink. Come on, what's wrong with me today? Okay, so take it out, put it together so we don't lose the screws. That does have a heatsink. Let me see. That does have a heatsink on that. Oh, the thing stays behind. No, does it? What a mess. How do they put these things together? Okay. Okay, I see what they've done. So underneath here, there's a little screw. That's underneath there. There we go. Come on. They're trying to stop you from tampering. Let's get it out of here. There we go. Right, that's that done. Then there'll be some little screws holding the board down. That's loose. Oh, there's another one here that holds the heatsink in place. And there's two more. Okay, there's two more of this. That's loose. And that's loose. So this is what part of what holds the board, and this fuse is popped as well. This, the fuse is also popped.
Okay.
I can see the fuse also popped. But if the fuse is popped, normally something else is gone as well. Yep, fuse is popped. Don't know, because of the power failure that we had, maybe we're too much of a hurry to take it apart. Normally the fuse is popped, something else is popped, huh?
Yes.
So there's one more screw on that side. Yep, here we go. See it out there, turn so you guys can see it. Yeah, you guys can see. Okay, here we go. And it's apart. Right. That over there. We can now start testing the devices. So there they've got this little insulator. There's some heat, it has some heat, but that's normal. I need to get one of those testers, those component testers, please. This is what we got here. It's a cap, it's over there somewhere. That's not good, huh?
No.
Short. Would like to go to the transformer coil or something.
There, it looks like it got hot.
Yeah, but I mean it's been in use for a couple of years. They can't all be blown. This is blown. Okay, here we go. Here we go. Start taking our stuff. Okay, so this is the tip I used for the IC last week. That video is still not out. So I still need to edit. Gently on that. There's that. Loose. And just get ourselves a nice tip to work on this. That should be okay. Let me see there. Where's the camera? That should be okay. Right. Change the tip before you put the soldering iron on. Otherwise, it gets a bit heavy. Okay, that's that. Let's put it on the soldering iron. And we're going to start taking out these semiconductors and start testing them out of circuit. Solder sucker is just somewhere. It's a solder weak. Yeah, solder sucker. I found another one of these. It was amongst my father's stuff here, so I came through. So, solder sucker. Not working 100%, but it's working. Right, that's there. Let's put some solder on this. We can put some flux, but where's my extra eyes? Just makes life a little bit easier. Yeah, it just makes life a little bit easier. Why is it sticking? What the hell happened? Yeah, in any case. Hey, there's a lot of solder on here. Yeah, I don't know what happened there. Just, yeah, thank you. That's right, thank you. Yes. Okay, I'd have to work on that one. Why is it not? Okay, that's out. Not out clean. Why is it not? Fish. Okay, it will come out in any case. What we'll do after this. It's really warm. Okay. Tire lever. Right, let's see if we can get some more solder off it now. Okay, that looks pretty good. Oh god, this one isn't going there. Okay, that's pretty clean. Here we go, that's out. That is out. It's warm, but we'll see now. We'll see if the short is still there when it's out of circuit. I think kaput. So this is blown. This is definitely blown. Okay, this is a 3DD13009. Okay, so this thing is definitely blown. Shorter.
And the fuse.
And the fuse also blown, yeah. Yeah. I'm starting to wonder. Well, we're gonna take the whole thing apart and see if in the end if it's even worthwhile repairing. See what the components cost, eh? Because sometimes it's not, eh?
Yep.
Sometimes it's not. So I've started using this. The guy at the shop said don't buy it. He doesn't like them. I've seen the guys using them. They exist for a reason. Okay, got a bit of stuff out. Those things exist for a reason because they obviously work for some people. A little solder, eh? Okay, looks like it's ready. Can take some off here. And oops. Ah, no, man. I always try not to get this thing entangled. Okay, that's how we come out. See, why is this middle pin always difficult on both add some more solder. Okay, and it is off. A lot of salt on that, huh?
They both the same.
I think so. I would imagine so, yeah. It looks like they're both the same and looks like they're both short in circuit. We need to take them out to see. Go the other side of the tie lever. Do like this. There's still too much solder. Unreal. And I can see the through hole quite clearly. Okay, we'll have to persist. Okay, let's put some apply some solder wick. This one must be difficult, huh?
Yeah.
Either that or got used to the small components now. Okay, it's loose. It's loose, but it's going to be warm now. It's going to be heavy. Heavy duty. Okay, so let's check this here. If they short meter, it's a meter. Yeah, that's it. They're both.
Both.
Third, yeah, same number. Still warm. That's the same number. I don't even know if the cost of these components, if it's going to be worthwhile repairing the power supply. Just let me put it on my. It's a different one. This is a Schottky diode. This is a Schottky diode. So we should get two diodes over here. But we didn't. Where's on that side there? The Schottky diode. I'm using a capacitor across. That's volume that you got. If I take it out as well. So I'm getting.
Maybe the transformer.
Yeah. So there's that. Jeez. That's how, no, I see a cap. Sorry guys, let me see. Maybe you guys aren't seeing the meter. Okay, so we do like this. See, it keeps on increasing on that. That's the capacitor that's in the circuit. You see that? That's the capacitor. We're not measuring the diodes. Let's try it both ways. Like that. This might be okay, eh? But the cap's in series or in the circuit, so that's not gonna. We have to take it out. We have to take it out to measure outside. So it is what it is. Oof, a little solder on here. This one is there and it can be difficult. There's something else here. There's a bridge. There's a bridge right across. No, it's gonna have to be solder wick again. This is where the cheap solder wick is good on places like this.
Yeah, just to suck it up.
Yeah, when you got bulk solder, so much solder, yeah. Jeez, I can't get this thing over the hole. Yeah, thanks. It's not going to. I'm gonna have to solder wick. Let me see which one is this. Yeah, yeah, I think it is. Jeez, a lot of solder in there. Okay. Gee. Okay, let's see. Let's just see that. Morning. Let's do some more solder wick. Is this. This must be loose now. There we go. Right, well that's still heavy. Here's the multimeter so you guys can see. Oof, that's low, eh?
No.
But see? That's fine, eh? That's fine. Okay guys, that's fine. So we have those two components that are popped. This is fine.
Same number. Same number.
No, those two. Yes, those two are the same. This is the socket height is different. Let's see over here. Hope you guys can see what I'm doing. Yeah, we're gonna put it back already, huh?
Yep.
Then it's back together already. I don't know what happened to the solder here. Jeez. Like entangled. Right. Apply some solder. And I don't even know if we're going to test the caps, Reese.
Yeah, I wonder what I saw.
That's not what I'm worried about. Is it even worthwhile testing the caps? I mean, those two devices are popped.
Yeah, I think it's still.
All the air for taking out the caps out of circuit. We can test some of them. The hole's not full there, but it's fine. It's soldered properly, Reese. You agree, eh?
Yeah.
on this. Yeah, there's it. Things all done properly now. Sorry guys, you probably can't see that. But I'll show you now. It's over there. So I don't have a problem soldering like this. It's just soldering the surface mounts that I'm busy learning. Can't even say I'm struggling because I'm learning. Okay, so that's fine. These, the caps all look fine, huh?
Yeah.
None of the caps are lifted or popped or...
And you must take the fuse out.
Yeah. Yeah, but the fuse I'll take out now. So this will work with these caps. No, yeah, that's fine, that. Oof. You know what? I need to clean this hole here as well. Need to clean this hole here as well. Over there. Okay, that's okay, there's it. It's open, right. It's open. This seems to work nicely. Seems to work nicely, so we'll see. We'll see as the usage continues. Right, at least that's all we're going to do now, eh? Need to go about components, eh?
Yeah.
The rest, what else can we test? That test okay? Everything else looks okay. Okay, let's take the fuse out then. This is a 5 amp. I don't know why I don't put a fuse holder in place here. Because I need to desolder the whole thing. Flip it. Put the meter off. We're going to clean up the board now to make sure it's here. Yeah, this is where I need that thing to hold the board, eh? Yeah, the thing I bought. Remember the thing I bought? Oh shit. You know what? No, keep it there. So. Swap hands. Straighten the leg. Because then it should just fall out. There's like that. See? Okay, let's see if it comes out. Well, let's see if it needs some more assistance. Thanks, Steve. Thank you. Thanks. It's loose. It needs a little bit of help. Yes, it fell out. So I don't know why. The idea is why do they make the fuses like this? That you have to solder it on the board. Right. I'm back. I went and bought spares for this. There's the original one. There's 2 equivalents. And let's see how that goes. Right, let's put on the solder station. That's on. Put in the soldering iron, and let's start getting ready for this. Okay. It wasn't in all the way, but how does it matter? Right, we start doing this, soldering iron up to temperature. Put on some right. And a little bit higher temperature. Let's see. Okay, that's there. I like the I like the level where it's at, straight, and I'm going to solder the rest of it. Okay. This thing's got big holes, lots of solder. No wonder. There's so much solder to get off here. I did it. That one there's in. I think it's a nice thing. Happy with that. Let's see how that goes. We'll keep on trying it. There's that. There's that. That's, yeah. That's why it's better to film early in the morning. There's less noise around. It's so like this. I think it's got big holes here. Okay, right. So now I can, hope you guys can see that. Right, that's there. Solder. That's nice. I'll show you guys if I cut. There's a big hole for this leads to go through. Right. Before I clean up, I'll show you guys the solder. You can see that. That's pretty good. That's right. I'm gonna cut the legs. And I'm going to clean the board, and then we're going to plug it in. Right, that's that. Some alcohol, my toothbrush, And we're going to clean what I didn't clean this morning. It's reasonably clean. So, you guys can see, it's pretty clean. That was there this morning. And these ones are pretty clean, right? Right, so let me get a lead. I've got a lead with bare wires here. Where is that lead with bare wires? See, we've got a lead here with bare wires. Okay, so we're gonna wire this up. We're gonna wire this up and see. There it's marked live and neutral and earth. I'm not going to put the heatsink on because we're not drawing any power. So it shouldn't get hot. If it gets hot and pops, then there's also obviously something else wrong with it. That's that. There's a problem with this screw. I lost this with taking it off. I don't know where it fell. Okay, it's on there. I don't know. I've probably got space somewhere from a power supply somewhere. We'll make a plan with that. There's a little strand over here. It's on a neutral. Okay, right. That looks good. Let's wire this up. Let me see. That's there. Everything else back together. Put the power off there. Everything else goes off. Doesn't matter. There, let me see, can you guys see the meter? On 12 volts, let's just see, before, let me close the alcohol, and it should work. Hope so it doesn't blow up. Oh shit, I didn't buy a fuse. Flip it, that's not going to work. I didn't buy a fuse. Shit. I went over to the shop, I didn't buy a fuse. Guys, I'm going to put a piece of wire across here. Let me unplug this. I'm going to put a very thin piece of wire across the fuse there. How the hell did I do that? So, guys, do not do this at home. So I want to ask something. You guys, it's difficult to ask you guys not to cheat. What's the function of a fuse? Most will say to protect the equipment. Nah, not really. Because fuses are way too slow. So by the time the fuse blows, it's already made other shit somewhere. So a fuse is there basically to stop fires. Because it takes too long to blow. So if there's a spike in power or something, I'll have to go buy a fuse. Shit. I was hoping to get this thing back into its position. Yeah. Okay. Make sure, shit. Okay, that's unplugged. It is unplugged. Shit. Stupido. Stupid. Yeah, because by the time the fuse blows, the damage is done to components. Components are damaged very, very quickly. Fuses can normally handle double the current for a couple of seconds. Let me see. There's a piece of wire. I threw two little strands. There. Right guys, I'm back. As I said to you, I'll put a fuse in there, take out the little wires. I'll put the little wires to test. Where is the fuse? There's a little fuse in there. There's a little pico fuse, it's a small one, it's still a 5 amp. So now we're going to test it. The multimeter is here. On 20 volts. Just going to plug it in for us here.
Okay.
And should be okay. Yeah,
Okay.
plug it in.
It's on.
It's on. Alright, there you go. There you go, 14 volts. Guys, it's fixed. Thanks very, very much for watching. If you'd like to buy me a coffee, yeah, I can unplug it. Thanks, Chris. You can buy me a coffee. Just hit the like button, subscribe. Thanks, guys. Cheers, cheers.